Hello and welcome back to video lecture on our microcontroller and embedded system. In this video, we are going to discuss the further topics of Model 3 embedded system components. The topic is memory. Memory is an important part of processor or controller based embedded system, and memory is used for storing either the programs or storing the data temporarily. The memory could be a inbuilt memory that comes with the integrated chip itself, or it may be connected external to the embedded system, or you can say integrated circuit. If the memory comes with the IC, then it is called as a built-in memory, also referred to as on-chip memory. If we are connecting memory externally to the IC, then we call it as a off-chip memory. There are two types of memory. First one is program storage memory, ROM memory, and other one is the RAM memory, random access memory. We'll discuss these two in detail. The first one is program storage memory, ROM memory. This memory is used to store the instructions or algorithm, or you can say the program, and it is a non-volatile memory. It means that when power goes off, the information present in this type memory will not be erased. It will retain there only. Depending on the fabrication, erasing and programming techniques, these type of memories are classified into masked ROM, that is MROM, PROM, or also OTP, one-time programmable ROM, EPROM, that is erasable programmable ROM, EEPROM, electrically erasable PROM, flash memory, and the non-volatile random access memory. Let me discuss these things in detail one by one. The first one is masked ROM, abbreviated as MROM. It is a one-time programmable memory. It means that once we program it, it cannot be reprogrammed for the further times. This type of memory makes use of hardwired technology for storing the data. Programming is done by masking and metallization process. This memory is of low cost, hence used in the low cost embedded devices, and it is used for high volume production. These are the least expensive type of memory, and this type of memory are having a limitation, that is inability to modify the device firmware against the firmware upgrades. Since it is a permanent, the bit storage is not possible to be altered, that is not possible to alter the bit information. Second type of ROM is programmable read-only memory, abbreviated as PROM. It is again OTP, one time programmable, in the sense we cannot program it for the second time and third time onwards. Here it is pre-programmed by the manufacturer. End user is responsible for programming these devices, and these memories are having nichrome or polysilicon wires arranged in a matrix, and these wires can be functionally wired as fuses. It is programmed by a pre-ROM programmer, and that programmer selectively burns the fuses according to the bit pattern to be stored. Fuses which are not blown or burned represents logic 1, whereas fuses which are blown and burned represent a logic 0. By default, value of these fuses is logic 1. These are low cost solution for commercial production. Erasable programmable read-only memory, abbreviated as EPROM. These type of memories give the flexibility to reprogram the memory IC again and again. This type of memory stores the information by charging the floating gate of an FET. Bit information is stored by using an EPROM programmer, which applies high voltage to charge the floating gate. These contain a quartz crystal window for erasing the stored information. If the window is exposed for ultraviolet rays for about 20 to 30 seconds, all the information will be erased. For reprogramming, we have to take the memory IC from the board, then erase it. So erasing of this is a tedious and time consuming process. Electrically erasable programmable read-only memory. The information can be altered by using electrical signals at the register or byte level. Can be erased and reprogrammed in the circuit itself. It means that we need not to remove the memory IC from the circuit board to erase it. This includes a chip erase mode, and the information can be erased in few milliseconds. This type of memory provides a greater flexibility for system design and having a limitation of capacity limited to only a few kilobytes. Flash is the latest and most popular ROM technology. It is a variation of EEPROM technology. It combines the reprogrammability of EEPROM and the high capacity of standard ROM. This flash is organized as sectors or blocks or pages, stores the information in an array of floating gate MOSFET transistors. Arranging of memory can be done at sector level or page level or block level without affecting the other sectors or other blocks or other pages. Each sector, block or page should be erased before reprogramming. Erasing capacity of this type of memory is of the order of few thousand cycles, whereas the endurance is of 1 lakh cycles. NVRAM, that is non-volatile RAM, is a static RAM with a minute battery backup, and this battery backup is for providing supply to the memory in the absence of external power supply. Both the memory and power battery are packed in a single package. The lifespan of this type of memory is around 10 years. DS1644 from the Maxim or Dallas Semiconductors company is an example of NVRAM that is having a capacity of 32 kilobytes. Then we'll move on to the second type of memory, that is RAM, read-write memory or random access memory. This is the data memory, working memory. Read-write in the sense we can read the data present in this type of memory, or we can read the data into this type of memory. It is a volatile memory. It means that whenever power goes off, the data present in this type of memory will be erased. Is a direct memory. It means that whichever the memory location we want to access, we can go to that memory address directly without traversing through the entire memory locations to reach the desired memory location. Whereas contrast to this direct access memory, we have sequential access memory. In that case, if you want to go to any particular memory location, we need to traverse through the entire memory, that is through a seek method. The examples of sequential access memory are magnetic tapes, CD-ROMs, etc. RAM generally falls into three categories: SRAM, static RAM, DRAM, dynamic RAM, and NVRAM, non-volatile RAM. Static RAM, a type of RAM, stores the data in the form of voltage. This type of memory is made up of flip-flops, and it is the fastest form of RAM. SRAM cell is realized using 6 transistors, that is 6 MOSFETs. Out of those 6 MOSFETs, 4 MOSFETs are used for building the latch or flip-flop, whereas 2 MOS transistors are used for controlling the access. The RAM, this type of RAM is fast because of its resistive network and switching capabilities. This can be visualized as 2 cross-coupled inverters with a read or write control through transistors, as shown in the figure. 4 transistors in the middle form the cross-coupled inverters. From the diagram, it is clear that access to the memory cell is controlled by the word line, that is bit line, here word line, and bit line B and bit line B bar. This word line controls the access transistors, that is MOSFET is Q5 and Q6. The access transistors control the connection to bit lines B and B bar. In order to write a value to the memory cell, apply the desired value to the bit control lines, that is for writing 1, make B equal to 1 and B bar equal to 0. For writing 0, make B equal to 0 and B bar equal to 1, and then assert the word line, that is word line has to be made high. For reading the content from this type of RAM, we have to assert both B and B bar bit lines to 1, and we have to assert the word line, that is making the word line high. It is having some limitations, and they are low capacity and high cost, and a minimum of 6 transistors are required for implementation of 1 bit of the cell. Next type of RAM, that is dynamic RAM. It stores the data in the form of charge. It is made up of MOS transistor gates. The advantages of this type of RAM are It is of high density and it is of low cost. And disadvantage of this type of RAM is that charge gets leaked off with time. We have to refresh the data present in this type of RAM repeatedly. So we are having DRAM controllers for refreshing operations, and this refreshing operation will be done in some milliseconds. The MOSFET acts as the gate for the incoming and outgoing data, whereas the capacitor acts as the bit storage bit as shown in the figure. See here we have a MOSFET, we have a bit line B, and we have a capacitor, and that capacitor is used for charging and discharging purposes, to store the value, and discharging that removes the values when it is not refreshed after some times. Let us discuss the differences between SRAM and DRAM. SRAM is made up of 6 transistors, whereas DRAM is made up of 1 transistor and a capacitor. SRAM does not require refreshing, whereas DRAM requires refreshing. SRAM is of low capacity, DRAM is of high capacity. SRAM is more expensive, DRAM is less expensive. SRAM is fast in operation, that is, the access time is 10 nanoseconds, whereas DRAM is slow in operation, which requires 60 nanoseconds for access. Then last type of RAM is NVRAM, that is non-volatile RAM. It is a static RAM with a minute battery backup, and the battery is used for providing supply to the memory in the absence of external power supply. Both the memory and battery are packed in a single package. The lifetime of this type of RAM is around 10 years. DS1644 from the Maxim or Dallas Semiconductor is an example of this type of RAM, which is of 32 kilobytes. Thank you. Remaining portions I will continue in the next video.